Now let's get into some of the resources that you guys provide. Earlier you mentioned the configurator tool, so I'm going to go ahead and pull up the configurator tool and we're going to do a live demo of how you can build a crossover platform or a work platform, whatever it is that your customer may need. So when you're on the Ballymore website, if you go to custom products, you'll see EAS, which we'll get into in a moment here. But first, we're going to start off with the configurator tool. So I'm going to go ahead and click on that. And John, why don't you just kind of instruct me on what to do at this point?
Sure. So what you're looking at here, we have 3 different applications that are designed that are quasi-modular in their production. There's a rooftop application that has rubberized rooftop feet to be non-penetrating on a rubber roof. The middle configurator is our carbon steel application. That is powder-coated yellow, carbon steel, or gray. It's modular, but not quite as modular as the multi-platform access system. The crossover ladder does have 1,000-pound load capacity, and it has the guardrails are welded onto the platform. Then you move over to the multi-platform access system. That is an aluminum, unpainted, mill finish aluminum system. It has the most modularity to it, and the beauty of that system is that when something's ordered, if something changes in the scope of what the work cell is doing, they can just simply unbolt a piece, order the new pieces that they need, and bolt it up to it kind of like a Lego kit. So it's designed to grow with a customer's advancement and changes in process with the customer.
Excellent. So let's just do a basic crossover ladder. I went ahead and clicked on that, and as you can see here, you have the different heights that you may want to check.
You have the heights for what the top of the platform surface is, but it also tells you what the clearance is underneath the platform. So there's a 2-inch difference between those. Are kind of critical points to key into to make sure that there's no interference point between what's underneath it and what it's going over. You have your choice of either grip strut or perforated tread. The grip strut is a much more aggressive tread for footing. The perforated tread is just a little less aggressive, and it probably reduces the amount of particles that may fall down through from someone's foot as they climb the stair. You have your choice of inclines, a 50-degree incline, a 75-degree. It's not a ship's ladder, but that's what people call it a lot of times because of the degree of approach, and then a 90-degree vertical ladder. Now you've got your stair selected, and so this system will bolt to the next piece, and so then you have your bridge choices, the 30-inch and a 20-inch bridge section, and then so you can click on one of those, and so that'll take you 30 inches. The cool thing about this system is that you can span up to 90 inches without having a support leg dropped underneath it. So if you've got a conveyance that's kind of wide, you can go up to 90 inches there. And if you click another piece, you see it's automatically going to drop that support leg in for you. If you make a mistake on that, you can just click the button to say remove the last part, and it'll pull that last piece out for you. Now, it'll do that on this one. The MPAS system does have a little bit of attitude, and there's a glitch in the code, and it's going to take a little bit more than what you want out, so you may have to go back and rebuild it.
So I just played around with it a little bit, gave it a couple of turns actually, gave it a left turn and then a right turn with a 90-degree step ladder going down. That way it could be forward-facing descent for that ladder.
Sorry, I was just going to point out while you're on that screen, in the upper left where the orange button is, it says top-down view. You can click on that, and a drawing is going to pop up on your screen, and it's going to show you exactly the footprint of what that system takes in space, so you can pull your tape measure out with your project manager and evaluate how this is going to sit on the production floor. And then on the right-hand side, you've got a parts list, and these are all in the Grainger website. Everything you need to quote the customer is right there in front of you.
It doesn't get much simpler than that.
It's an awesome tool. You can screenshot that and save that parts list, and that way the rep can enter that into the Grainger website and generate their quote. They don't really need to come to us for a quote for that because Grainger has their own pricing on this.
Yeah, and if you need any help with that too, you could just copy those part numbers down, email it to myself. I'll look it up, or somebody at Rowe-Thrush will look it up. We'll give you the Grainger SKUs for that application. That way your customer can order it through regular ordering processes.
And one thing about that, depending on the size and the number of pieces, most of the time that's about a 5 to 10 business day lead time. The whole idea is that you, right in front of the customer, you can have a concept model, you can have a drawing, you can have a quote, and you've got a really fast lead time. So those are very strong selling points to be competitive in the market. And against other modular platform manufacturers that are out there, we're about 40 to 60% more competitive in price.
Excellent to hear, especially the lead time. I can't help but feel like everybody these days, they want everything now. Thanks to Amazon, Netflix, it just everything's on demand. So everybody wants it very quickly. So that's great to hear. Is there anything else that you wanted to cover about the configurator tool before we move on to EAS?
It is a segue into EAS. So this is a standard line product, and the reason that we have such good lead times on this product is that all of these parts are built in a fixture. And so the materials get laid down on the fixture, and the welder will go down and he'll weld those components together and then pull it out of the fixture and then drop the new piece right in. So it's made for high speed throughput and fast productivity.